Good morning friends, heartily welcome to my YouTube channel. So we are in the discussion of JEE, right? So we have started with matrices, different concepts we have finished. We have seen what are the different types of matrices, special matrices. Then we have also seen the trace of a matrix, how to calculate its trace, and also we have seen what is the adjoint of a matrix, then how to calculate adjoint very quickly using a short trick, that also we have seen. And these all things, that may be the types of matrices, special matrices or a trace of matrix, everything we have seen with one simple examples. So now let's move on to the next topic. So today's topic is inverse of a square matrix, right? So inverse only exists for square matrix, not for any other particular matrix. Okay, so if matrix is square matrix, then only we can find its inverse. It is not compulsory that every square matrix should have inverse, right? But if inverse is existing, then definitely it will exist for a square matrix. Okay, so let's begin with today's session. So what is the inverse of a matrix, right? So inverse of, if you consider any particular matrix A, right? So we can say that that particular matrix A is having inverse if and only if there is one more matrix B. There is one more matrix B which is existing, right? So of the same order as that of A. If A is of order 3 cross 3, B also should be a matrix of order 3 cross 3. If A is of order 2 cross 2, B also should be of order 2 cross 2. So whatever matrix A is there, same matrix B should also be there. There should be a matrix B of same order as that of A, right? So this is one more first condition. What is the second condition? If I multiply A into B, that should be equal to B into A. Generally, in matrix multiplication, A into B will not be equal to B into A, right? That property is not satisfying, because we have seen that when we are solving in NCERT matrices, right? A into B will not be equal to B into A. If A into B is equal to B into A, and in turn that should be equal to I, right? What is I? Identity matrix. If this condition is satisfied, A into B should be equal to B into A, and that should also be equal to I, alright? Or IN, where N is the order of matrix A and B. Same order should be taken for I also. I is what? Identity matrix, right? So if these two conditions are satisfying, first one is A and B matrices should be of the same order. Then A into B should be equal to B into A, and that should be equal to I, right? Identity matrix of same order as that of A and B. Then we can say that A is having inverse, or there exists inverse for matrix A. Okay, then if inverse is existing, what we can say? A in that particular matrix B itself will be the inverse of A. Then I can say that B is the inverse of A, or A inverse is equal to B. So let's see what is the definition is about to say of these things. A non-singular matrix, this is also very important. A non-singular matrix. What is non-singular matrix? Determinant A should not be equal to 0. Determinant A, if it is equal to 0, then there is no existing of matrices. There is no existence of inverse, right? That is also one important thing. A non-singular square matrix A is invertible. Invertible means it is inverse is existing for that particular matrix. If and only if there exists a square matrix B such that A into B is equal to B into A is equal to IN, where N is the order of matrices A and B. That's the condition, right? So if that is there, what we can say? We can say that inverse of A is B, and we can write A inverse as equal to B. And we also know that, friends, A into adjoint A is equal to adjoint A into A is equal to determinant A into I. There is a property given when we have studied about adjoint, right? So what is that? A into adjoint A is equal to adjoint A into A, that is equal to determinant A, right? So now what will be A inverse? If I equate this thing, A into anything, these two things or these two things, anything you can equate and you can calculate the value of A inverse. So adjoint A into A will be determinant A into IN. What is IN? Identity matrix whose value will be 1. So you can neglect. I can write adjoint A into A is equal to determinant A. So if I want to calculate, if what will be A? A will be determinant A divided by adjoint A. A will be determinant A divided by adjoint A. So what will be my inverse? Reverse of that. 1 upon determinant A into adjoint A. So A inverse can be written as 1 over determinant A into adjoint A. If I take A here and if I bring determinant here, then 1 upon A is nothing but A inverse. So A inverse will be adjoint A divided by determinant A. That is nothing but written as 1 over determinant A into adjoint A. So this is how we can calculate A inverse also, right? So A inverse can be calculated by row transformations and column transformations also. A into A inverse is equal to I, making use of that particular property. But it takes, if the problem is simpler, if the matrix is simple, it will take 4 to 5 steps. If it is complex, it may take 10 to 12 steps, right? So that is other thing, right? So one more way is by calculating the adjoint A. Determinant A can be calculated easily within a step, and adjoint A can be calculated in two ways. One is by conventional method, calculating minus and cofactors, then going for transpose of cofactor matrix, then we get the adjoint A, right? Using that adjoint A, we can calculate the A inverse. And second method for calculating adjoint A is what I explained in the previous session, that is calculating it with the tricks, right? So now you might have understood how important the trick is, right? So if you are able to calculate adjoint A within a step, then within 2 steps you will be able to calculate the A inverse. That is why the calculation of adjoint A is very important for us as far as it is concerned with your competitive part, right? To calculate the A inverse. So now pause a moment, have a look at this and make a note of this. Okay friends, I hope you have understood that previous slide. So let's move on to the next topic, that is in the same inverse of matrix. So let's see what are the properties of inverse of any matrix. Okay, so first one here is every invertible matrix possesses a unique inverse. That means if B is inverse of A, then we can also say A is inverse of B, right? So if B is inverse of A, then only B will be inverse of A. Apart from B, we cannot say any other matrix will exist that will be inverse of A. That already we have proven in our NCERT playlist. You can see that one, NCERT videos. If there exists inverse for any particular matrix, that inverse will be unique. There cannot exist any other matrix, different matrix which is inverse of one particular matrix. That is, two different matrices cannot form inverse of one common matrix. If A is a matrix and if B is inverse of A, then any other matrix apart from B cannot be inverse of A, like B and C. It is not possible. So B and C are different matrices and inverse of A, that is not possible, right? So we have proved that one, taking B, considering B and C as inverse of matrices, and we have proven that B and C both are same. You can refer that one. If B is inverse of A, then only B is inverse of A. Apart from B, there does not exist any different matrix which is inverse of A. That is the meaning of first one, right? Second one, if A and B are invertible matrices, then AB is also invertible, and given by AB whole inverse is equal to B inverse into A inverse, right? So if A and B are invertible matrices, right? If A and B are invertible matrices, then A into B is a matrix which is also invertible. That means A into B is also having inverse, and whose inverse is given by B inverse into A inverse. So you can see AB whole inverse is equal to B inverse into A inverse. This is writing in reverse way. A into B whole inverse is B inverse into A inverse. If it is A into C whole inverse, that will be C inverse into A inverse. Similarly, if A, B, C, so on, up to any number of matrices are invertible, if all are invertible, then A into B into C, so on up to the matrix which you have considered. Multiple of all the matrices is a matrix which is also invertible and is given by from end. If A, B, C and D, if you are taken up to E, then it starts from E into D into C into B into A. Reverse, whatever will last here, it will be first here, right? It will start reverse here, okay? So that is how the inverse of a product of any two matrices will be there. Next, if A is the invertible matrix, then A transpose is also invertible matrix. Third point is, if A is invertible, then A transpose is also invertible. So you can write A transpose inverse, inverse of A transpose as transpose of A inverse, inverse of A transpose as transpose of A inverse. And next one, if A is invertible matrix, then adjoint of A transpose can be written as transpose of adjoint A. If A is an invertible matrix, then adjoint of A transpose can be written as transpose of adjoint A, right? And this one, fifth point, if A is a non-singular matrix, non-singular means whose determinant is not equal to 0. That is the main condition for calculating the A inverse, right? If A is a non-singular matrix, then determinant of inverse of A, determinant of A inverse is equal to inverse of determinant A. Inverse of determinant A. Determinant of A inverse is inverse of determinant A or determinant A inverse. Right? So which can, that is nothing but what? Determinant of A, inverse of determinant A means it is nothing but 1 upon determinant A. Okay. So this is also very important. This point you should always note. This is appearing again and again in your competitive. In many state boards that is asked, right? And sometimes it is also asked in your JEE also. This is very important part, right? Determinant of A inverse is equal to. They will ask directly, or they will give you the some values, right? So then they may ask you to calculate the. They will give you matrix A. They will ask you to calculate determinant of A inverse. Then you should use this one. And lastly, inverse of kth power of A. Inverse of kth power A is equal to kth power of inverse of A. Inverse of kth power of A means what? Kth power of A is A to the power k. Kth power of A is A to the power k. Inverse of this kth power of A, that is A to the power k whole inverse, is nothing but what? Kth power of inverse of A. Right? Kth power of inverse of A. This is also the condition which is given. So friends, these are the properties which you have to be aware, right? So you always remember that the trick for adjoint of matrix is very important. It plays a very important role for you people to calculate the inverse of A. Once you apply the trick, then at the last step we need to take the transpose of that one, right? By applying the trick we will get the cofactor matrix, then take the transpose, then directly we will get the adjoint A. Right? Once you get adjoint A, you can use that in 1 upon determinant A into adjoint A, then you are going to get the value of A inverse. Okay? This is how it is given here. Right? So go through this all properties. Whatever properties are there, they form very important part of your competitive exams. Questions will definitely come on these properties. So be prepared. Take care. Right? So in next video, we are going to solve some problems on adjoint of problems on inverse of A. Then we are going to solve different problems also on different concepts. These days we have covered many concepts, that is trace of A, adjoint, all the things. In adjoint of A, I have solved almost 2 to 3 problems. There is more than enough. Still we'll solve 1 or 2 problems. Then we can we can move on to the next topic. Okay. So in next upcoming classes we'll solve a couple of problems on inverse of A. Then we'll take different problems. So it will be easy for you people. So till then, take care. Goodbye.